This is the second video on the method of elimination that we can use to solve systems. It's essentially the same method, but what's a little bit different is that sometimes when you want to use elimination, you're looking at a problem and you can't see anything to eliminate. So if we look at this first example, we have 4a minus 3b equals -8 and 2a plus 2b equals 3. I'm looking at this, and right now the a's don't share a coefficient and the b's don't share a coefficient, so what can I do? When we are solving using elimination, if we need to, we can manipulate one of the equations so that it will work to use elimination. And when to do that, we're going to use multiplication. So what I mean by multiplication is when you multiply one or both of the equations by a common factor, a common multiple, to create a coefficient that can be eliminated. So if I'm looking at this first example, and I want to give us a little bit of room, so I'm going to move it over a little bit this way. So I'm looking at this first example. Right now, I don't see anything that I can eliminate. But what we can do is we can multiply one or both of our equations by a number and create a coefficient that is the same. So what the easiest thing that we can do is I'm going to set up a little chart for myself right here with the number, and here is going to be the multiples. And I'm going to see what are these two things have in common. So you can pick either of them. You could pick the 4 and the 2 or the 3 and the 2. I'm just going to pick the first two. The numbers that I'm going to try to get to be the same number are 4 and 2. Then I'm going to ask myself, okay, what is 4 times 1? What is 4 times 2? What is 4 times 3? What is 4 times 4? Until I see that they have a common number. So 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. And if you don't know these off the top of your head, it's okay to use your calculator. Let's see about 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. Now, I notice that these have two numbers that are in common. Right here, they both have a multiple in common of 4. They also both have the multiple of 8 in common. Now, it does not matter which one you use. You could use the 4 as a common multiple. You could use the 8. What you need to notice, though, is that this is already a 4. In order to make this a 4, I only would have to multiply this equation, and that's a little bit easier. To make them both 8s, I would have to multiply both. So I know that to get this into a 4, I need to do 2 times 2. So I'm going to multiply this entire equation by 2. Notice that I put parentheses around the answer as well, what it equals. You're multiplying the entire thing. So to give myself a little bit more room, I'm going to go ahead and I'm going to erase this. So copy down if you need it. Two times 2a is going to give me 4a. 2 times 2b is going to give me 4b. And 2 times 3 is going to give me 6. A common mistake that a lot of students make is that they forget to multiply the answer. So distribute that 2 to everything. And then this equation is going to stay the same. 4a minus 3b equals -8. Now, if I wanted to use elimination to solve this, I now have something I can eliminate. I notice that I have 4 in front of the a, so the coefficient of a is 4. How do I get 4 and 4 to be 0? Do I add them or subtract them? Well, 4 plus 4 is going to give me 8. 4 minus 4 is going to give me 0. So I'm going to subtract these two different equations. 4a minus 4a gives me 0a. Negative 3 minus 4 gives me, do that on your calculator, give you a second. You should have gotten negative 7b. Be careful that you're doing a negative 3 minus a positive 4. And then don't forget your answers. We're going to do a negative 8 minus 6, which is negative 14. Essentially, I don't need this 0a, so I really just have negative 7b equals negative 14. I'm going to go ahead and I'm going to get b alone, so I'm going to divide both sides by negative 7. These negative 7s cancel out, and negative 14 divided by negative 7 is a positive 2. So right now I have that b is positive 2. I still need to find a in order to solve this system. When you go back to solve the system, I would use one of the original equations. If you happen to make a mistake here, it'll show up when you check your answers. So use one of the original equations to solve for b. You can use either one. It does not matter. I'm just going to use the first one. So I have to solve for a. So I have 4a minus 3b equals negative 8. I know that b is 2, so I'm going to put 4a minus 3. b is positive 2. I'm going to go ahead and see if I can simplify anything, and I notice that I can do 3 times 2. 3 times 2 is 6. This is now a two-step equation. How do I get a alone? First, I'm going to add 6 to both sides. I'm going to have that 4a is equal to negative 8 plus 6 gives me a negative 2. If I divide both sides by 4, I'm going to get that a is equal to negative 1/2. So right now I think that b is 2. I think that a is negative 1/2. Now, any good mathematician should always check their answer. It's really, really important that you check your answer because we could have made a mistake. So let's see if we made a mistake. I'm going to check with both equations, and I'm going to use these two original equations. So 4a minus 3b equals negative 8. And the second equation, 2a plus 2b is equal to 3. So I'm going to go and substitute in my numbers. A was negative 1/2. B was 2. And let's see if it works. 4 times negative 1/2 is negative 2. 3 times 2 is negative 6. Negative 2 minus 6 is negative 8. That works. Let's check our second equation. 2 times a, which was negative 1/2, plus 2 times b, which was 2. 2 times a negative 1/2 is going to give us negative 1. 2 times 2 is 4. And negative 1 plus 4 is positive 3. Positive 3. So I got 3 equals 3. My check worked. So my solution is that b equals 2 and a equals negative 1/2. Let's do another example so you can see all the different ways that this might work. Alright, so this is our second example, and we're going to use the method of elimination. So I'm looking at this and I'm seeing, okay, is there anything that I can eliminate? Do the x's share a coefficient? No, a 4 and a 6. Do the y's share a coefficient? No. So what I need to do is I'm going to need to multiply one or both of the equations so that I can cancel something. Now when I'm looking at this, right now, I can choose to change the coefficients for x's to be the same, or I can choose to change the coefficients for the y to be the same. It does not matter. I'm going to go ahead and I'm going to figure out what are some common multiples that the numbers have in common. And I'm going to use, last time we used the x's, so this time I'm going to use the y's. So I have a 5 and I have a 7. Now I know this is a negative 7, but we can still cancel something that if one's positive and one's negative. So I'm just going to go ahead and I'm going to figure out what do they have in common. So let's see, if I multiplied it by 1, by 2, by 3, by 4, by 5, what do they have in common? All right, 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. And 7 times 5 is 35. Alright, I just went up to 5 multiples and I still don't have anything in common. If this happens, there's 2 things that you could do. The easiest thing to do is just to multiply the equations by each other. So what I mean by that is to say 5 and 7, when you multiply them together, so if I kept going and I went up to 6 and 7, 5 times 6 is 30, 5 times 7 is 35. They have a multiple in common, which is when you multiply them by each other. So the first thing I could have done is I could have just said, okay, I'm going to multiply this one by 7, I'm going to multiply this one by 5, so that this will turn into 35, because 5 times 7 is 35, and turn this one into 35. 7 times 5 is 35. When you need to multiply one or both of the equations, that's an easy way for you to do it really quickly. It's just multiply the 2 equations by each other. If you don't want to do that and you want to find a smaller number, you could also go back and see if 6 and 4 have a common factor. If we did that, we would see that they both go into 12. I want to show you right now how that if you multiply the 2 equations by each other, it still works. So we're going to go ahead and multiply this one by 7, so it becomes 35, and this one by 5, so that it becomes 35. I'm going to go ahead and erase this so I have a little bit more room. Alright, so we have to multiply both equations. So 7 times 4 is going to be 28x. 7 times 5 is going to give me 35y. And don't forget the answer, 7 times 6 is going to give me 42. Now, so the second equation is 5 times 6x is going to give me 30x. 5 times a negative 7y is going to give me a negative 35y. It's really important that you remember, you notice if there's minuses there so that you get this as a negative 35. And 5 times a negative 20 is going to give me a negative 100. Make sure you're multiplying by all 3 of the terms. Alright, now you should notice that there's something we can eliminate. The y has a coefficient of 35. How do I get 35 and negative 35 to be 0? Add or subtract? Well, positive 35 minus negative 35 is going to give me a negative 70, so that doesn't work. Let's try adding. A positive 35 plus a negative 35 gives me a 0y, and that's what I want. I want this to eliminate. So I'm going to go ahead and add everything else. 28 plus 30 gives me a 58x. And 42 plus a negative 100 is going to give me a negative 58. Notice that you're adding these 2. Alright, we don't really need this 0y, so really what I have is 58x equals negative 58. I want to get x alone, so I'm going to go ahead and divide both sides by 58. And I get that x is going to be equal to negative 1. Once I have x, I can go ahead and solve for y. You can use either of these equations to solve for y. Last time we used the first one, so I'll use the second one this time. I'm going to use the original equation. 6x minus 7y is going to be equal to negative 20. I know that x is negative 1, so 6 times negative 1 minus 7y equals negative 20. I'm going to go ahead and simplify this. So I have a negative 6 minus 7y is equal to negative 20. I want to get y alone, so the first thing I'm going to do is add 6 to both sides. Negative 20 plus 6 is going to give me a negative 14. If If I divide both sides by -7 to get y by itself, I get that, y, not x, very solve for x, these cancel out, y is going to be equal to a +2. So right now, I have that x is -1, and I have that y is +2. So I'm going to go ahead and I'm going to write out my solution. My solution, I think, is going to be -1, comma, +2. Now, I need to check this. I need to make sure that it's correct. So I'm going to use my two original equations. 4x plus 5y equals 6, and 6x minus 7y equals -20. Alright, let's see if it works. 4 times x is going to be -1. 5 times y is going to be 2. So 4 times -1 is -4. 5 times 2 is 10. -4 plus 10 gives you 6. That one works. Let's try this next one. 6 times x, which was -1. 7 times y, which was 2, equals -20. 6 times -1 is -6. -7 times 2 is -14. And -6 minus 14 gives you -20. Our check works on both of these. Because our check works, we know that our solution is going to be, our solution is going to be -1, comma 2. Something else to note is in our last solution, our last example, we wrote our answer as a equals and b equals. Remember that if you're solving for x and y, you can write it as a coordinate point. If you're solving for two variables that aren't x and y, like our previous example, so let me go back to that one real quick. That's why we wrote this as b and a. We can't write that as a coordinate pair because those aren't x and y. But if it is x and y, we're going to write that as a coordinate pair, -1, comma 2. Alright, here is some practice for you to do. Notice you're going to do practice 1, practice 4, practice 5 from your packet. Go ahead, pause the video, try these 3 different practices, and then when you're ready, come back and I will give you the solutions and a little bit of an explanation. Alright, so for practice number 1, first of all, you should have multiplied. You had a couple of options. You could have tried to get these x's to be the same. I'm going to go ahead and write this one out underneath. 2x plus 3y equals 6, and x plus 2y equals 5. You could have multiplied this first equation by 2. That would have made this become 2x plus 4y equals 10. And you'd have your top equation 2x plus 3y equals 6. You could have gotten rid of these two x's by subtracting everything else, which would have given you a solution of -3, comma 4. For practice number 4, I'm going to rewrite these two. You would have had 3x minus 2y equals -7, and 2x minus 5y equals 10. You had to multiply both equations, so you could have either changed your x's or your y's. I'm going to try to make these 2 into 6, so multiply this first equation by 2 and this second equation by 3, multiplying it by each other. That would have given you 6x minus 4y equals -14. On the bottom, you would have had 6x minus 15y equals 30. You could have subtracted your 6 x's, so you have to subtract everything else. Be careful here. This is a -4 minus a -15. Your solution should have been -5, -4. And then on this last one, I'm going to rewrite them, would have had 4x minus 2y equals 32. Looks like an x. And you'd have had a -3x minus 5y equals -11. You would have had to multiply both equations. You could have either changed these to be the same or these. I'll just pretend like you changed your x's. So the common factor these two have in common is 12. So I would have multiplied this by 3 and this by 4. For that top equation, you would have had 12x minus 6y equals 64. And for this bottom equation, you would have had a negative 12x minus 20y is equal to negative 44. You could have gotten rid of these by adding, and so you would have added everything else, and your solution should have been 7, negative 2. Alright, if you are still unsure or have questions, please write them down or rewatch the video and be ready to practice in class.